Ohio everyone! Today we'll be going over how to code linear regression. Before we get to the coding, let's have a look at our sample data. Here we have the number of sauces used in a sandwich on the x-axis, and the taste value of said sandwich on the y-axis. According to Desmos, the graphing calculator I used, the best fit line is 0.924x plus 0.313. With this in mind, let's get on with the coding. If you've watched my previous video, you'll know that we have two methods. We'll start with the gradient descent method. Using the pseudocode and equations we covered in the previous video, linear regression is rather easy to code. First, we declare our step size and initial guess. You might need to play around with the step size depending on your data, but we'll use 0.01. Since we're assuming our error function is parabolic, choosing an arbitrary initial guess at the weight poses no problem. I chose an array of zeros with the size equal to the amount of inputs. If, however, our error function looks something like this, then choosing an arbitrary initial guess could lead us to a local minimum instead of the global minimum, resulting in an unoptimized weight vector. Then we make a for loop for an arbitrary number of iterations, decrement our step size with each iteration, and then make a stochastic gradient descent loop. The SGD loop loops over every data point, so first we extract a data point, calculate the predicted output according to our weight vector, then calculate the derivative of the error function for that input, and then decrement our guess for the weight vector accordingly. When we run this code, our obtained equation is y equals 0.979x plus 0.194, which is quite different from the one we got in Desmos. The second method is even simpler. We first need to separate our data into two different lists, inputs and outputs. Then we simply use this equation. Though I wrote it out in 4 lines, this program can be done in 1 line. The obtained weight vector is exactly what we get from Desmos, 0.924x plus 0.313. These codes can also apply linear regression on datasets with more than 2 inputs, since the amount of inputs is not a constraint in any step of either code. It should be noted that linear models aren't useful in all situations, like daily temperature or population growth. Linear models also cannot accurately predict data following sinusoidal, logarithmic, exponential, quadratic, cubic trends, and so on. To solve this issue, we simply need to substitute x with f of x, and our programs will optimize for f of x. Here is an example using a sine wave. And that's all for now. Adios, pelolotes.